Trifas, would you like to introduce your student?
Yes. Good afternoon. So Matthew Glavosek, he has completed the 3 programming courses in our program, and he would like to just explain a bit how different types of interfaces are perceived by the users. And I'll just, without further ado, I'll let him start, okay?
My name is Matthew Glavosek, and my presentation is on image processing in Python and building better interaction interfaces. So we're going to be talking about types of interfaces, like command-based or virtual reality. Then we got our case study, since it's tax season, so we got to put that in there. And a terminal-based version, then we'll have a GUI-based version with that. And then we got widgets as GUI components. And then I'll show some image processing algorithms. So we got many types of interface styles. So we got command, which is the oldest, and we'll see an example soon of it. But a computer responds to commands typed by the user, so it has a little bit of a learning curve for less computer whiz people. And then we got speech, which can be described as like Alexa, so you're telling anything how to do it. You got data entry, where you have little fields on where you put the information in. And then you got the form fill-in, which is a more better version of that. A simplified data entry with that. And then we got query, which you're asked multiple questions and then you answer them, and then that's how you do it. Then you got graphical, which is GUI, so you have different graphics, you're able to interact with that. You have the web, which more so is web design, so HTML, CSS, stuff like that. Then you got the pen, which is like Apple Pencil or like a stylus that you use. And then you got augmented reality, so an example would be like Pokemon Go. So you take a virtual thing, you put it into real life. And then you got gesture, which an example of that would be like Nintendo Wii or like a Kinect or something like that, where you use your motion and it actually gets processed into the to the game. So first off, we got command line. So you type in the prompt and you have abbreviations with it typed in the prompt to which the system responds. So you just type in a prompt and then it will do whatever it tells you to do. Some are hardwired to the keyboard, while some others are assigned to the keys. And it's efficient, precise, and it's fast, but it has a little bit of a learning curve, since not everybody's going to be able to know the exact prompts and the exact commands that you need to in the computer. And then we got Second Life, which is a command line based interface for the visually impaired users. So pretty much you would tell it, say hello, smile, good to see you. And then the player in the game would actually do it. I was told through some research that some people found their spouse in this game from a while ago. But that's an example of a command line based interface. And then we got GUI. So Xerox Star was the first to give rise to the GUIs. And we got windows in this GUI. There's sections of the screen which can be moved, scrolled, and everything, to where you can just interact with it and you move it around the screen. You got icons, like an icon on a desktop, to where they represent your applications and objects and everything they use in the computer. Then you got menus, which they list of options that you can scroll through, pretty much like if you right click and you have like a line of stuff that you can do. So that's the menu. Then you got your pointing device, which is like your mouse and everything else. Your cursor, to where you can interact with the screen on yourself. Then you got multimedia. Combines different media within a single interface, which various forms of interactivity. You got graphics, text, video, sound, and animation. Pretty much just mix everything together in one application. Users click on links in an image or text, so where another part of the program, an animation or a video clip is played, or users can return to where they were and move on to another place. So they can just either go back or just keep on going through the application. They can provide better ways of presenting information than a single media can. And this is an example of a multimedia learning app. So we got this app that pretty much, if you scroll left and right, it'll show either the present or the past version of a Roman Colosseum. And you can either go back to the past, or you can go up to the present. And it's interchangeable. So now we got the case study. So we got the income tax calculator. So the customer requests a program that computes a person's income tax. So the first off, you got to realize what you're going to be doing with that. So you got to write the algorithm. So you got pretty much the input, the gross income, the number of dependents. Then you compute the taxable income using the formula. Then you got taxable income, gross income minus 10,000 minus 3,000 times the number of dependents. Then you got to compute the tax using the formula. So pretty much after that, you got to implement your code. So then you put it all into the coding language of your choice, and then it should display it. But we have two different versions we can do. So we got the terminal-based version, which is it'll just tell you, okay, input this, and then you input that, and then it'll just input all of your information that you got. Not too elegant, not too user-friendly. Then we got GUI-based. So we have designated spots where you actually put in the information, and then it'll output your calculation. So it's a lot more user-friendly, and I'm sure anyone in this room would rather have this rather than a command line based. So now we're going to go into image processing. So we perceive our light differently than how it actually is. Color is continuous. It's really, really small, like 370 to 730 nanometers. So it's really small how we perceive it. We perceive a light with the color sensors that peak around either 425 nanometers for blue, 550 nanometers for green, and 560 nanometers for red. Our brain figures out which color that we're being perceived whichever sensor is responding to that light that's coming to our eyes. One application is we perceive two kinds of orange, one that's spectral and one that's red and yellow. Hits our color sensors just right for that. Dogs and other simpler animals have only two kinds of sensors. They see color, but they just see less color than humans do. Now, luminance versus color. So we perceive borders of things, motion, depth, via luminance. Luminance is not the amount of light, but our perception of the amount of light. We see blue as darker than red, even if same amount of light. So pretty much, luminance is actually colorblind. We don't actually see it, but it's a complete part of the brain than with color than with luminance. So digitizing pictures as bunches of little dots, pretty much. So the little dots are called pixels, and they have really tiny little dots on the screen that just flow together so that our naked eye will actually be able to just perceive it as a flow of colors and a flow of an image. Enough dots will just pretty much make it look like a full picture rather than you just see the little tiny little dots. And our eye is a limited resolution with it. So our background, depth, acuity is particularly low. Each picture element is referred to as a pixel, as I stated. And pixels are picture elements. So each pixel object knows its color, and it knows where it is in this picture that it's in. So whenever we zoom into a really low resolution pixel or picture, you'll see each individual pixel and each tiny little part of it. You can tell just how it actually flows together so we can actually see it. And a picture is just a matrix of pixels. So it's not a continuous line of elements that is an array. A picture has two dimensions, width and height. We need a two-dimensional array, a matrix, so that it'll actually flow together and it'll actually become an actual picture. So then we encode color a different way than how you think. So each pixel encodes color at that position in the picture. So we have different types of encodings for pictures. We have printers use CMYK, which is cyan, magenta, yellow, and black. Others use HSB for hue, saturation, and brightness. But in computers, we use RGB, red, green, and blue. So how we encode RGB is each component color, red, green, and blue, is encoded as a single byte. Colors go from 000 to 255, 255, and 255. If all three components are the same, the color is in grayscale. So that's in 200, 200, 200 at 3, 1. 0, 0, 0 is black. And 255 all around is white. As you can see, we have red, which is 255, 30, 30. We got blue, 30, 30, 255, and so on. So as we implemented into Python, we used a package from Lambert, from images import image, and we used this program called Grayscale. So pretty much how this goes is it goes in every single y coordinate of the picture that we're using, and every x coordinate, and it'll go through and multiply the actual pixel by a certain amount, which each number in that's being multiplied by is from psychology, where it's like we perceive green more than blue and so on. So we pretty much just add all those up, and then we put in the luminance as we stated. And then this program specifically only uses GIFs. And my references are Kenneth Lambert, Fundamentals of Python. We got Helen Sharp, Giovanni Rogers, Jennifer Priest from Interaction Design and Beyond HCL. And my acknowledgments at the MCIS department, JSU, and thank you all for coming. Any questions?
So, will you talk a little bit more about that function you just showed?
About the function?
Yeah. So, would you mind reiterating the part about RGB?
Oh, RGB?
You talked about luminance before, and then this part again. Could you explain that?
Oh, we're talking about, so we have, pretty much each pixel is going to be evaluated to where if it has an amount of red, amount of green, and amount of blue. So it'll multiply that certain amount by the set value that it is given.
So, in this case, the G is the biggest of those, right? Doesn't that mean that we see G less, and so it's trying to compensate by making it bigger? And we see blue more, so it's trying to shrink it by making that factor so small?
It's pretty much just trying to make every value the same so that it can be a grayscale.
Right.
Sorry. Anything else?
Other questions about a kicker?
So the coding in the middle produced the bottom right photo?
Yes, ma'am.
Okay. I'm glad you asked that question. That makes sense.
Yes, ma'am.
I don't know anything about this, but I play Sims. So would this fall on like the GUI system that you're talking about?
Mhm.
Oh, cool.
It would.
Cool. Sims 4.
Any other questions?
All right, well, let's thank our speaker.